or larger. So let's talk about it. The setup is this. Yeah, out of towering cumulonimbus clouds, got strong updrafts, got a lot of wind energy. Cold air aloft is the main culprit, along with a strong upper level trough with that cold air aloft moving in. That warm, moist, unstable air hits that cold air aloft, and that creates an ideal environment for hail development and formation. So here's what we're talking about. Look at the various hail sizes. Hopefully you can see this full enough, and I'll point it out and illustrate it. So here's the severe levels. We've got quarter size right here, which is 1 inch in diameter. So there's quarter, 1 inch. What is ping pong ball size? 1.5 inches. What's golf ball size? 1 3/4, 1 3/4 in diameter. There's hen egg size as 2 inches in diameter. So look at tennis ball, 2.5 inches in diameter. And so that's looks like, we could say if it wasn't tennis ball, it was at least racquetball size. In today's modern times, we could almost say it could have been pickleball size, but we'll keep it tennis ball size. Little levity there. Baseball is 2 3/4 inches in diameter. We don't want to see that. And of course, look at softball, 4 inches, and grapefruit, 4.5 inches in diameter. So that's usually confined to the Plain States and Colorado. They get big hail out there, but that's what we've seen. We've had confirmations of quarter size hail, and again, just looking, we've had anywhere from quarter to golf ball to egg size in some areas, but we could have just seen in Tallahassee up to tennis ball size hail. Now, here's kind of an interesting graphic. Meteorologist Mike Simon put this graphic together earlier this afternoon. In order to get large hail, here's what's going on. You have updrafts and downdrafts in a thunderstorm. It's kind of like milking a cow, okay, for lack of a better description. You got friction as the air goes up in a thunderstorm and down. You got those water droplets rubbing against each other. By the way, that's how you have electricity in a thunderstorm cloud, separating the ions, electrical ions in the cloud. And that separates the positive charged particles that go to the bottom part of the cloud, and the negative charged ions, the particles, that go to the top part of the cloud. So that creates thunderstorms like a battery. And again, that's what we're seeing. Actually, I think I've said that reverse. Positive on top, negative on bottom. So it's like a battery, positive on top, negative on bottom. And that's also what creates the lightning. Well, what else is going on? The updrafts and downdrafts, you got those strong winds that are propelling those droplets that take it, and then it gets below freezing. If the freezing level is low, like today's setup is, below freezing levels, that water droplet forms a layer of ice. That's how a hailstone forms. So you go up in the cloud, gets below freezing, it forms a layer of ice, and it comes back down in the cloud. Think of the milk and the cow, updrafts and downdrafts. Again, that's where we're seeing it gets caught back up in the cloud with the updraft, comes down. You've got a loop current going on in severe thunderstorms with large hail. It stays in the cloud until it gets too heavy and it falls out. What determines the length of time that it can grow a hailstone in that thunderstorm cloud? The winds. So take a look at this. If we have, for example, if we had that egg to tennis ball size hail, look at these winds, 70 to 77 miles per hour within a thunderstorm. Now that's severe winds, but we're talking about the updraft speed. And so that's pretty strong. You got 70 to 75 mile per hour winds just being thrust upward into that thunderstorm, taking that droplet of water way up tall in that cloud. And that's how, with those winds, it can keep that hailstone suspended within the thunderstorm cloud. That's how it can grow larger. And by the way, safely, you can actually cut open a hailstone and you can count the rings in the hailstone, the layers, and that tells you how many loops it made. So just like you count the tree rings on a stump, a tree stump, that tells you how old, how many years the tree grew. So that's how you count the number of years on a tree, tell how old it is. Same thing kind of in general with the hailstone. You can count the rings or the layers. That tells you how many loops, trips around the thunderstorm, within the thunderstorm that it made. So just a little bit of some